The storm sat 30 miles offshore and simply refused to move for hours. It hung there like a held breath, spinning at 150 miles per hour, staring at the islands, and the islands stared back. That is not how typhoons are supposed to behave. Typhoons move, they track, they curve, they follow the steering currents of the atmosphere, and they leave. This one did not leave. This one waited. And that decision, that almost deliberate stillness, turned what would have been a catastrophic direct hit into something that meteorologists are now calling historically significant in the worst possible way. But that is not even the real story. The real story is not about the wind speed or the storm surge or the downed power lines that have plunged 50,000 Americans into total darkness right now as you watch this video. The real story is about why a Category 5 super typhoon is hitting these islands in April. Not August, not September, not October, when the Western Pacific typhoon season typically reaches its most lethal peak, but April, months before the season has even properly begun. The real story is about what the ocean temperature readings taken in the days before Sinlaku formed are telling us about the water beneath that system, and why those numbers represent something that scientists are calling deeply alarming, even in careful, measured language. The real story is about a chain of islands that has already survived the most powerful tropical cyclone ever to strike United States territory, less than 8 years ago, and is now being asked to survive it again. And beneath all of that, beneath the data and the declared emergencies and the flooded streets of Garapan, is a question that nobody on those islands, and nobody in any position of authority in Washington, can honestly answer right now. The question is not whether these islands will be hit again. The question is whether they will ever have enough time between hits to fully recover before the next one comes. Let us start with what the data actually shows about Sinlaku, because the numbers are almost incomprehensible when you translate them into human scale. On Sunday, April 13th, 2026, the Japan Meteorological Agency recorded Sinlaku's central pressure at 905 millibars. For reference, a standard atmospheric pressure at sea level is 1,013 millibars. What that 108 millibar difference means in physical reality is this: the air pressure at the center of that storm was so catastrophically low that the ocean surface beneath the eye was physically lifting. The sea itself was being sucked upward toward the sky, creating a dome of water that would later slam into coastlines as a wall of churning ocean 18 feet high. 18 feet. Stand in your house right now and look at your ceiling. In most homes, you are looking at about 8 or 9 feet. The storm surge that rolled into the western coast of Saipan, into the streets of central Garapan, was twice the height of the room you're sitting in, and it was moving. When Sinlaku peaked over open ocean on that Sunday, the Joint Typhoon Warning Center measured its sustained winds at 180 miles per hour, with gusts exceeding that threshold with each rotation of the eye wall. 180 miles per hour. Most people have never driven a car at even half that speed. The fastest production car on a closed track barely reaches that number. Sinlaku was spinning winds at that velocity continuously for hours over hundreds of square miles. The NASA Suomi NPP satellite captured Sinlaku on April 13th, and the image, released by NASA Earth Observatory, shows a structure of almost terrifying beauty. A perfectly symmetrical vortex, a clean, defined eye surrounded by concentric rings of deepening cloud, the kind of formation that meteorologists describe as a classic annular typhoon structure, and which exists in that state only when every atmospheric and oceanic variable is aligned in exactly the wrong direction for anyone living in the storm's path. At the time that image was taken, Sinlaku was a violent typhoon on the Japan Meteorological Agency scale, their highest category, equivalent to a Category 5 on the Saffir-Simpson wind scale used in the United States. The warm waters beneath it measured 28 to 29 degrees Celsius at the surface, which is 82 to 84 degrees Fahrenheit. Waters that in any previous century would have been unremarkable in summer, but are now occurring in April. The ocean heat content beneath the storm reached 125 to 150 kilojoules per square centimeter, meaning the warmth did not exist just at the surface. It extended deep into the water column, a reservoir of thermal energy so vast that even as Sinlaku churned through it, mixing cooler water upward from below, it could not exhaust the fuel available. Scientists who study rapid intensification, the process by which a tropical system escalates in strength by 35 miles per hour or more in a 24-hour period, have a phrase for what those numbers represent. They call it a supercharged environment. And here's where this story becomes genuinely alarming. In the days before Sinlaku formed and began its race toward the Marianas, ocean surface temperatures in that region were running 3 to 5 degrees Fahrenheit above the recent average. And that recent average is itself already warmer than most of the 20th century. 3 to 5 degrees does not sound like much. But in the physics of tropical cyclone intensification, 3 to 5 degrees is the difference between a storm that struggles to organize and a storm that explodes. It is the difference between a Category 2 that grazes an island and a Category 5 that sits offshore for hours, spinning. The atmosphere above those waters had vertical wind shear of only 5 to 10 knots. Wind shear being the force that tears tropical systems apart before they can organize, meaning Sinlaku faced almost no resistance whatsoever as it built itself into a monster. Low shear, extreme heat, extreme depth of warm water. Every single variable pointing in one direction. This is not a theory. This is documented meteorology. And the question that Yale Climate Connections and other serious scientific institutions are now asking publicly is not whether this combination of factors will occur again. The question is, how often? Now let us talk about where this storm went. The Northern Mariana Islands form an arc of volcanic peaks in the western Pacific Ocean, roughly 1,500 miles east of the Philippines and 1,500 miles south of Tokyo. Most Americans have never thought about these islands, which is itself a kind of tragedy, because these are American territory, home to American citizens, people who carry American passports and pay taxes to the United States Treasury and are entitled to every protection that designation implies. Saipan is the largest of the inhabited islands, and it is home to approximately 45,000 people. Picture a city the size of a mid-sized American college town. Now picture that town on a tropical island 12 miles long and 5.5 miles wide, surrounded entirely by open ocean, with the nearest major landmass thousands of miles away. The people who live in Garapan, Saipan's main urban center crowded along the western coast, wake up in the morning and look out at the Philippine Sea. They send their children to school. They go to work. They eat in the same restaurants. They stop at the same stores. On Tinian, the smaller island 7 miles to the south of Saipan, roughly 3,000 people live among the sugarcane fields and the old Japanese airfields and the concrete pads from which, in August of 1945, the B-29 bombers Enola Gay and Boxcar took off carrying the atomic bombs that ended the Second World War. These are not abstract places. These are communities. And on the night of April 14th, 2026, those communities took a direct hit from Super Typhoon Sinlaku at 150 miles per hour. The mayor of Saipan, Ramon Jose Blas Camacho, known to his constituents as RB, was communicating with the Associated Press as the storm made landfall. His words were not the careful language of an official managing a situation for public consumption. They were the words of a man watching his island come apart. He said Sinlaku was hitting us hard. He said it was so difficult to respond with the heavy rain and heavy wind to rescue people. He said objects were flying left and right. As he spoke, his first responders were still sheltering in place, unable to move through the streets, because the streets no longer existed as streets. They had become rivers of wind and water and debris, carrying with them pieces of roofs and utility poles and trees that had been uprooted entire, root ball and all, from the volcanic soil. By early morning on April 15th, both Saipan and Tinian had gone entirely dark. Not partially dark, not dark in some neighborhoods. Island-wide power outage. Every light on both islands gone. Internet connections down. Cell service sporadic at best. The islands had effectively been severed from the outside world at the moment they most desperately needed to communicate with it. What the data actually shows about the storm's behavior in those hours is something that forecasters will be studying for years. Sinlaku had become nearly stationary approximately 30 miles off the coast of the archipelago before making its final approach, hovering for hours while its feeder bands lashed the islands with preliminary destruction. Weak steering currents, the atmospheric rivers that normally push typhoons along their tracks, had essentially abandoned Sinlaku, leaving it to drift at a walking pace, sometimes as slow as 3 miles per hour. 3 miles per hour. A healthy adult walks faster than that. What this meant in practice was that the islands did not experience a typhoon passing over them. They experienced a typhoon parking on top of them. The destructive wind field sat over Saipan and Tinian, not for the 2 or 3 hours typical of a fast-moving system, but for most of a full day, grinding against structures, stripping bark from trees, lifting roof sheets and carrying them into neighboring buildings. Even after the eye passed and the worst of the winds theoretically began to ease, sustained gusts of 60 to 70 miles per hour continued battering the islands. Winds that, in any other context, would constitute a dangerous tropical storm in their own right. This is not a theory. This is documented geology and meteorology, and it has happened before. On October 24th, 2018, less than 8 years ago, Super Typhoon U2 made landfall on Tinian and then Saipan with maximum sustained winds of 175 miles per hour and gusts reaching 220 miles per hour. 220 miles per hour. That is not a wind speed. That is a force of nature operating at the boundary of what structural engineering anywhere on Earth is designed to withstand. The National Weather Service meteorologist Brandon Aidlet stood in the aftermath and said, with no exaggeration detectable in his voice, that Saipan and Tinian would be unrecognizable. He was right. U2 destroyed up to 6,000 homes across the two islands. It toppled 962 power poles, Not knocked over, not damaged, toppled, leaving both islands without electrical power for months. Not days, months. More than a quarter of the 45,000 plus residents of Saipan were left homeless by a single storm that passed in a matter of hours. 2 women were killed. 121 to 133 people were injured. Total economic damage exceeded $800 million, a staggering sum for islands with a combined economy smaller than a mid-sized American county. The Saipan campus of Northern Mariana's College, the island's primary institution of higher education, had 85% of its buildings destroyed. The school's president, Galvin de Leon Guerrero, spent the next 8 years securing $100 million in grant funding just to rebuild what one night had taken away. Yutu was the strongest tropical cyclone ever recorded to strike United States territory, tied only with the 1935 Labor Day hurricane in Florida's Keys, which had been a different era, a different ocean, a different world. And the people of Saipan and Tinian rebuilt. They did what island communities throughout human history have always done. They cleared the debris, they raised the walls, they restrung the power lines, they sent their children back to school in tents while the buildings were reconstructed around them. 8 years of grinding, exhausting, underfunded recovery. And then, on the morning of April 14, 2026, the radar screens at the National Weather Service office in Tian, Guam, lit up with a signature that followed almost the exact same track as Yutu had followed 8 years before. President de Leon Guerrero, watching the storm approach, said what every person on those islands was thinking. Just as we were finally beginning to recover and rebuild, we get hit with this. He added, climate change is real. Here is what the connected systems are showing us because no event of this magnitude happens in isolation. The Western Pacific Ocean in early April of 2026 was in a state that meteorologists describe as primed. The La Niña cycle that had developed weekly in late 2025 was transitioning toward neutral ENSO conditions, a transition that historically tends to leave the Western Pacific with elevated sea surface temperatures and reduced wind shear in the lower and middle troposphere, exactly the combination that Sinlaku exploited. Sinlaku was not the first Category 5 storm of 2026. Tropical cyclone Horatio had already peaked at 160 miles per hour over the South Indian Ocean in late February, far from any populated coastline, almost unreported. 2 Category 5 storms before the Western Pacific typhoon season's official statistical peak. The 1990 to 2025 average for Category 5 storms globally was 5.3 per year. That number is trending upward, and while science is careful about attributing individual storms to climate change, the same caution does not apply to trends. The trend is documented, peer-reviewed, and is measured in the geological record as surely as it is measured in the NOAA buoy readings taken last week. Research published in Science Advances has quantified that continued upper ocean warming under even moderate climate scenarios is expected to increase average typhoon intensity by an additional 14% by 2100. 14% more intense than Sinlaku. Take the storm that just darkened 50,000 Americans. Translate every number 14% upward, and ask yourself what that looks like when it arrives at a coastline. Meanwhile, consider what the ocean heat content data tells us about the second connected system. The same warm, deep waters that fueled Sinlaku's rapid intensification are present across a broad swath of the Western Pacific, from the waters south of Japan all the way down through the Carolines and the Marshalls and the Marianas. When a typhoon passes over these waters, it mixes them, cooling the surface temporarily. But in a high ocean heat content environment, the cooling is partial and temporary. The warm water refills the surface layer faster than it used to, meaning the recovery time between one storm's fuel consumption and the next storm's exploitation of that same fuel is shortening. Scientists are careful to say this relationship is complex and probabilistic, but that careful language carries its own warning. The ocean is not returning to pre-industrial temperatures. The ocean is warming. The storms are feeding from that warmth. The Northern Mariana Islands sit in the most active basin on Earth for tropical cyclone formation, and the basin is getting warmer every decade. Right now, in the darkness of Saipan, there are families who do not yet know the full extent of what surrounds them. First responders are sheltering in place because the winds of 60 to 70 miles per hour that followed Sinlaku's passage are still strong enough to turn debris into projectiles. Parts of Garapan's western coast are inundated. Vehicles are submerged. Roads are blocked by fallen trees and utility poles. The FEMA distribution center in Guam has been stocked with 1.1 million liters of water, 723,000 meals, 5,300 cots, 3,600 blankets, and 4,400 tarps. But getting those supplies from Guam to Saipan requires ports and airports that are not yet assessed for safety, roads that are not yet cleared, aircraft that are not yet able to fly. On Tinian, where 3,000 people live in a community so small that almost everyone knows almost everyone else, The darkness is total, and the silence between gusts is filled only with the sound of rain, the creak of structures that absorbed whatever Sinlaku had to give and are now being asked whether they can hold until morning. The federal emergency declaration that President Trump approved ahead of the storm's arrival was important. The 90 FEMA personnel already positioned in Guam and the CNMI are important. The 42 additional generators en route to Saipan are important. But the people of Garapan, and the people of Tinian's San Jose village, and the people of every coastal community that took the storm surge directly, they know what the data also shows, which is that a declared emergency is a promise of help that takes time to arrive, and the hours between a typhoon's passage and the first supply convoy reaching your neighborhood are among the longest hours a human being can experience. The mayor of Saipan is trying to get rescue teams moving through flooded streets. Internet connection in the CNMI remains intermittent at best. Efforts to contact people on the ground are meeting limited success. These are not abstractions. These are the conditions inside which 50,000 people are waking up on April 15th, 2026. What the full damage picture will ultimately show is not yet knowable. Sinlaku's slow movement means the assessment teams are still waiting for conditions to permit their first survey flights. The most recent updates from the CNMI's Office of Homeland Security and Emergency Management note that many sensors on the island were rendered inoperative by the storm itself. The very instruments designed to measure what happened were destroyed by what happened. The National Weather Service station estimates. The satellite reads what the clouds permit it to read. The ground truth will come from the people who live there when they are safe enough to describe what they saw. And history, in the form of U2's aftermath in 2018, provides the template for what that description is likely to contain. Extensive structural damage, infrastructure that will require months to rebuild, a population that is resilient, that is proud, that is Chamorro and Carolinian and deeply connected to these islands, and that will begin rebuilding before the water has fully receded, because that is what they have always done. And yet the question that the data keeps forcing into focus is not about resilience. The people of the Marianas have demonstrated their resilience beyond any reasonable need for proof. The question is about arithmetic. The question is about what happens to a community's ability to recover when the interval between catastrophic storms compresses. When Typhoon Sinlaku hit in 2015 and U2 hit in 2018, the community had 3 years. When U2 hit in 2018 and Sinlaku hit in 2026, the community had 8 years. Years spent largely in reconstruction. Years during which the Northern Marianas College president was chasing $100 million just to rebuild the campus. What the trend in Pacific Ocean temperatures suggests, and what the trend in Category 5 storm frequency suggests, and what the behavior of Sinlaku in April rather than October of 2026 suggests, is that the arithmetic of recovery is becoming less generous. Scientists are careful to say, and that careful language carries its own warning, that individual storms cannot be prevented, and their tracks cannot be controlled, and their intensities cannot be undone once they are formed. The monitoring is in place, the warnings are issued, the evacuations are ordered, the FEMA warehouses are stocked, and all of that matters enormously in the difference between a storm that kills dozens and a storm that kills thousands. But the monitoring does not reduce the wind speed. The warning does not cool the ocean. The emergency declaration does not rebuild the 962 power poles before the next storm finds them. Sinlaku is currently moving away from the Marianas. It has begun curving northward toward the sparsely populated volcanic islands of the far northern chain. Pagan, Alamagan, Agrihan, before meteorologists expect it to complete an extratropical transition as wind shear increases and it passes into colder waters. The threat to Saipan and Tinian as a direct strike is over. What is not over is the darkness. What is not over is the blocked roads and the inundated coastlines and the structures that may or may not be standing in Garapan right now. What is not over is the period between the last sensor reading and the first full damage assessment, which is when the true scale of what happened is tabulated into a number, and the number is compared to U2's $800 million, and the rebuilding calculus begins again. There is one more thing the data shows. Sinlaku's name was contributed by the Federated States of Micronesia. In the traditional cosmology of Kosrae Island, Sinlaku is the goddess of nature and bred fruit, a figure of fertility and provision and the cycles of life that the ocean and the forest sustain. That a storm bearing her name would return to these Pacific islands and take from them what she was meant to give is not a scientific observation. It is something older. But what is scientific, documented, measured, peer-reviewed, published in every major atmospheric research journal in the world, is this. The ocean temperatures that made Sinlaku possible are not an anomaly. They are a new baseline. And the next storm forming in those waters will find them just as warm or warmer, and will make the same choices Sinlaku made. And the islands will be in its path, as they have always been, because that is where they are. 50,000 people are in the dark tonight on American soil in the Pacific Ocean. The question is not whether it will happen again. The question is whether, by the time it does, the lights will have come back on.